Assalamualaikum warahmatullahi wabarakatuh. I am Nur Shamina binti Soimi and I am from class J4 EE114B1. So today I want to explain about the assignment ELE242, which is I am required to simulate and calculate the operational amplifier. Okay, so before we move to the calculation parts, I want to explain a little bit about the operational amplifier. So an operational amplifier is an integrated circuit that can amplify with electric signals. It also has two input pins and one output pins, and its basic role is to amplify the output and the voltage difference between the two inputs. Alright, this is the first question, which is the separator circuit. In this circuit, I have to find the V node here. Alright, so let's go to the calculation part. Alright, so first of all, I do the calculation part. Alright, so to calculate V node, I need to find the V plus at the operational amplifier here. So I apply the VDR. Because it has two resistors here, which is in parallel, and the voltage I want to find is at 1 kilo resistor. So I apply the VDR and use the current, the voltage supply here, which is 9 volt, and get the answer of 3 volts. So which is this? As this is the ideal operational amplifier, so V plus equals to V minus, which is 3 volt, and then the current in, and I apply the current in and current out method. So to find the V out, so V1 equals to V2, which is 10 minus 3 over 1k equals to 3 minus V node over 1k, and I get a value of V node, which is negative 4 volt. Alright, so to confirm this is the right answer, so I do the simulation part. Alright, let's go to the simulation part.
Okay, so for the simulation part, first of all, I place all the components needed, which is the operational amplifier, the resistors, the ground, the voltage supplies, and VEE, VCC, and also the multimeter. And then after that, I connect all the components to become a circuit. And then the VCC I use is 5 volt, and the VEE is negative 5 volt, because this is the value of VCC is the bigger than the output, and the VCC is less than the output. So to find the voltage, I use the multimeter.
Alright, so this is the questions 2, which is it is the combination of two operational amplifier circuits, and I have to determine the V node 1 here and V node 2 here. Let's go to the calculation. Alright, this is the questions 2, the answer of question 2. So first of all, I consider A1. So I find the V plus here by using the VDR, same as like before. 18k over 80 plus 30 times 3 volt, and I get a value of 1.125 volt. And then I use the current in and current out to find the V node 1 here. So I substitute all the value and then get the answer of V node 1, which is negative 8.563 volt. Right, so by looking at A2, this is the voltage summing, which is it has two resistor here, and the voltage the resistor here is connected to the ground. So this is the voltage summing. So I have to use the superposition theorem, so which is to apply one input at a time and determine the corresponding output, and then combine the result. So first of all, I consider the output due to V node to 1, which is I grounded here. I ground here, and then I calculate all the answers. So first of all, I find the V plus here, V plus, by using the VDR at here, because this is the grounded resistor. So 15k over 50k plus 30k times negative 8.563, which is the value of V01, because the V in is using V01. So I get a value of V plus is negative 3.67 volt. And alright, so V negative equals to V plus, which is negative 3.6 volt. And then I use the current in and current out to find the V02. But this is V.21. Alright, so I get the value of I substitute all the value and get the value of V01, V021 equals to negative 11.281 volt. Right, so the second consideration is output due to V022. Alright, so this time I ground it here and then get the value, supply the voltage at 0.7 here. Alright, so first I find the V plus, which is at the grounded resistor, which is 20k resistor, and get the value of 0.4 volt, and V minus equals to V plus, which is 0.4 volt. And then I use the current in and current out at at I5 and I6, and I get the value of V022, which is 1.23 volt. And then the answer is I must to add the V022 and V021 to get the V02 total, which is a negative 10.051 volt. Alright, so to check whether this answer is correct or not, I have to run the simulation, and let's go to the simulation part.
So for the simulation of question 2, I use the same method, which is I took out all the components needed, which is the voltage supplies, the ground, the resistors, the operational amplifier, and also the multimeter to calculate to determine the voltage at the output. And then I connect all the component to become the circuit. And in this question, it used for the first one, it used the voltage subtractor circuit, and the second operational amplifier, it used voltage summing. So and then I connect it. Question 2, I used a VCC negative 15 because the output that I calculate is negative 10.051, so it have to be smaller than the output. And then I change all the value of the resistors and currents, the voltage supplies, follow the questions, and then I run the simulation and get to the voltage. So the voltage that I got from the multimeter is negative 10.015 volt. And here I forgot to insert the multimeter at the V01, so the V01 that I got is negative 8.54, which is same as calculation.
Alright, let's move to the question 3, which is the combination of operational amplifier 2, and I have to find the V note here. So let's go to the calculation part. This is the calculation part, and first of all I consider A1 and A2. So first I have to find the V plus here, V minus here, V plus here, V voltage supply is 10 volts, so V minus equals to V plus, which is equals to 10 volt. And then V voltage supply here is 5 volt. It makes the V plus equals to 5 volt and V minus equals to 5 volt. Right, so I use the current in and current out, and I consider this is I1 and this is I2, I3, I4, I5, I6 and I7. So to determine the V02, I'm sorry, I forgot to, this is P node. To determine the V node here is V01 here is to using I1 equals to I2. So I substitute all the answer, the value here, which is V01 minus 10 volt over 1.5k equals to 10 volt minus 5 volt over 1.2k. So I get a value of 16.25 volt. Right, so next is to find the V02, which is I use current in and current out again, and this time I use at I1, at I2 and I3. So I substitute all the value and then get the answer of V02, which is negative 1.25 volt. Right, so the next step is I consider A3. So at A3, I must find the voltage at the operational amplifier. So to find the voltage operational amplifier V plus here is I need to find the V03 here. So I use the current in and current out because I don't know the voltage supply here. So the current in and current out, which is I4 equals to I5. So I've substituted all the value and get the value of V03, which is negative 0.75. And then this is the answer. This is the value of V minus for operational amplifier of A3. So and then I can calculate the value of V0 by using current in current out again at I1 and I7. So this is the value, the final value of V0, which is negative 17.75 volt. Alright, so let's go to the simulation part.
For question 2, I used the same method, which is I took out all the component needed, which is the resistor, the operational amplifier, the voltage supply, the ground, and then and the last one is the multimeter. And at this circuit, I have to make sure the connection is correct because the positive and the negative might affect my output value. So I have to invert all the component if it is not in the right positions. The VCC and the VCC I use is 20 volt and the VEE I use is negative 20 volt. And at this circuit, it consists of 4 output, which is V out 1, V out 2, V out 3, and V out node. So for the V out 1, I get the value of 16.25, and for V out 2, I got the value of negative 1.249, and for value of V3 is negative 749.259 millivolt, and the last one is V out, which is negative 17.746. And all the value that I get is same as the calculation. So this is proof. The answer that I calculate is correct.
Okay, this is the question, and this is the last question, which is to find the V01 here and V02 here and V03. So let's go. Okay, this is the calculation for question 4, and first of all I consider A1, which is here, and find the value, the voltage at A1, which is 0, because the V minus here is connected to the ground, so which means the V minus equals to 0, and also the V plus equals to 0 volt. Right, and to find the V01, I use the current in and current out, which is I consider this is I1, this is I2, and this is I3. So current in is I1 and I2, I1 plus I2, and current out is I3. So I substitute all the value and get the final is negative 4.5 volt. And then I consider A2, which is this is the buffer voltage, buffer of voltage follower, which is there's no resistor, no current supplies here, so which is it makes the V output equals to V in. So that is why the which is the V supply is 2 volt and makes the V output also the 2 volt. Alright, so and then the next steps is I consider A3, which is I use the current in and current out at here, at node here, and I assume this is I4, this is I5, and this is I6, and current in, which is I4 plus I5 equals to I6, and then I can get the value of V node 3, which is 7.33 volt. Right, so let's go to the simulation part.
And the last simulation is at the question 4. Same as before, I took out all the component needed, and then I connected all the components to become the circuit. And at this question, it consists of the first amplifier is non-inverting, the second one is the voltage follower, and the third one is the inverting operational amplifier. The VCC used is 10 volt and the VEE is -10, and this circuit consists of V node 1 and V node 2 and V output V node, and V node 1 I got the value of -4.503 volt, V node 2 1.999 volt, and the last one is V output, which is 7.343 volt, and all the value is same like the calculation, so this is proof.
Alright, that's all for me, and thank you so much.